A very good morning to all my dear students. Today we are going to start with a new chapter, that is sound, chapter 12 for physics. Okay. So in this chapter we are going to discuss about sound and so many activities we will discuss to show that vibrating bodies produces sound, and some more activities to show that sound needs material medium for its propagation. The types of waves also we will discuss. Along with that, we will discuss about compression, rarefaction, and we will discuss the relationship between speed v, frequency nu, and wavelength lambda of sound. We will discuss about echo, reverberation, and characteristics of sound when we hear it. Other than that, we will also discuss about internal structure of human ear and laws of reflection of sound. So many things we are going to discuss in this chapter. So, first of all, I would like to start with a small intro of sound. What is sound? When I say this word, what comes in your mind first? Avas, right? I'm speaking and you are able to hear me. This is sound. See, so many types of energy we are having around us, like heat energy, solar energy, potential energy, kinetic energy, thermal energy, chemical energy, right? So sound is also a form of energy like all these, which causes a sensation of hearing in our ears. Sound cannot be created nor be destroyed, but can be changed from one form to another. A very simple example we can give: when I clap, a sound is produced. So, what is happening over here? The muscular energy, my muscular energy is getting converted into sound energy. So, this is also like law of conservation of energy. Okay. Similarly, another example we can give for electric bell. When connected to electricity, starts producing sound. Here again, electrical energy is converted into sound energy. Okay. Now we'll discuss about production of sound, how the sound is being produced. As I've told you earlier also, that sound is always being produced through vibrations. When vibration occurs, then sound is being produced. What happened when I'll strike on the table? Vibrations. As I've told you in previous chapter, that solid particles are not able to flow. What they'll do, they are just able to vibrate. They will just do to and fro motion, the oscillation. What is vibration? Vibration is a kind of rapid to and fro motion, which could be said as oscillation also, right? So, motion of material causes vibration, and vibration is the reason for the sound to be produced. A very simple example we can give for this: a stretched rubber band. What will happen if I'll stretch a rubber band and I'll pluck it? Vibrations. Right? If I'll plug that stretched rubber band, vibrations will be produced and thus the sound will be produced. Okay. Another activity we can give to show that vibrating bodies produces sound. What I'm doing, I have taken a tuning fork. Okay. What is tuning fork exactly? It's a U shape. It is having a U shape, having a handle at the bottom. So I'm holding it from the lower part, and I'm striking these prongs of the tuning fork on a rubber pad. Now if I'll bring it near my ear, what I'll be able to hear? The sound, just because of the vibration occurring in this tuning fork. Few more examples we can give to explain this, that how sounds are produced. If I talk about us, the human beings, if I talk about me, I'm speaking right now. How you are able to hear my sound? How my sound is being produced? Through the vibrations. Where the vibrations are being produced? In my larynx, in my voice box. So when vibrations are being produced in my larynx, then You will be able to hear my sound. The sound is being produced. Okay. Another example we can give for stringed musical instrument like sitar, guitar, veena, etc. So there is a tightly stretched string to produce sound. Another example we can give for bird also. When a bird flaps its wings, a sound is produced, right? So can we say that sound is being produced through vibrations? Alright, so next topic that we are going to discuss is propagation of sound. What I mean by propagation? Propagation is actually traveling of sound. Traveling of sound is called propagation. Okay. So sound is propagated by the to and fro movement of particles. Okay. So how sound is being produced, how sound propagates, how it travels through to and fro motion of the particles of the medium. And when an object vibrates, it sets the particle of the medium around it vibrating. So, can sound travel through solid, liquid, gas, all the three mediums? Yes, it can. How can I say that sound can go through solids and liquids and gases? We will discuss some activities to prove these things. First of all, come to the solids. If I am saying that sound can travel through solids, how I'll be able to prove this? What I have done for this activity, I'm having a table in front of me and I'm tapping on one end of the table or I'm striking it from the one end. And another person is standing at the other corner. Will he be able to hear the sound if I'll tap on this end? Yes, he or she will be able to hear the sound. Right? How? Because when I'm striking on one end, what happens? The sound will travel through the particles of solid. The vibrations are being produced in these particles. And this disturbance is being carried forward to that end. And that person will be able to hear the sound. Alright? Another example for solids, I can give you the very simple example of your class. If you guys are sitting in a classroom, you are making a lot of noise over there, but you have closed your door. Will your voice reach up to the other classes? Obviously, it will reach. But why? You have closed the door now, and you must be thinking that your sound must not be reaching to them, but it will reach. Maybe a little bit fainter, but it will reach, right? Because sound can travel through solids. Okay, now come to the liquids. If I talk about liquids, sound can also travel through liquids. How I can prove this? If anybody is doing swimming and if he or she shouts from there under the water, will we be able to hear the sound? Yes, we will be. That will be a little bit fainter again, but the sound will be audible. Okay, another activity we can do this to prove that sound can travel through liquids. And what is that? If I have taken a bucket half filled with water and I have taken a squeaky toy also along with that. Squeaky toy, everybody must be aware, which makes sound. So what I am doing, I have taken that squeaky toy and I have put that squeaky toy in a poly bag. Now I am putting this poly bag into that half filled bucket. Now I am allowing that squeaky toy to make sound. I am pressing it. Will I be able to hear the sound? Yes, I'll be able to hear the sound. A fainter sound I'll be able to hear, right? So can we say that sound can travel through liquids? Alright? So now come to the gases. If I talk about gas, how I'll be able to say that sound can propagate through that also? Sound can propagate through gases, because when I am speaking, you are able to hear me. What it means? That my sound is reaching up to you through air, right? So can we say that sound can propagate through all the three mediums? Sound needs a material medium to propagate. It always needs medium to propagate. Medium is necessary for the propagation of sound, and that's why its waves are called mechanical waves. Alright? Sound waves are also known as mechanical waves because it always needs medium to propagate. Alright? Sound propagates as a wave. Sound always goes from one place to another in the form of waves because of disturbance of particles of the medium. Okay, and what is wave? Wave क्या होती है? Disturbance होता है, right? It is a phenomena or disturbance in which energy is being transferred to one point to another without any direct contact between the points. So sound is considered as a wave. Again, I am repeating myself. What is wave? Wave is a phenomena or disturbance in which energy is transferred from one point to another without any direct contact. कोई direct contact नहीं है इनके बीच में, तब भी वो वहाँ तक पहुँच रहा है. किस फॉर्म में? वेव फॉर्म में, right? But light shows rectilinear propagation, as I have told you earlier also. How can we say that light shows rectilinear propagation? If I have taken a pipe and I am having a candle with me, okay, I have lighted that candle and the flame of that candle I have put it on one end of the pipe. Will I be able to see that flame through other end if the pipe is straight? Yes, I will be. But if I'll bend that pipe from somewhere, will I be able to see that flame now? Never. Why? Because light shows rectilinear propagation. It always travels in a straight direction, but not with sound. Sound always travel in the form of waves. So there are two types of waves mainly: longitudinal waves and transverse wave. If I talk about longitudinal waves के अंदर particles क्या करते हैं? Move करते हैं एक place से दूसरी place पर. In these particles do not move from one place to another. क्या करते हैं? Oscillate करते हैं, to and fro movement करते हैं अपनी ही position के around, right? So अगर मैं example की बात करूँ, longitudinal waves का बहुत अच्छा example है sound waves. And next is transverse waves. Transverse waves are the types of waves जिसके अंदर जो particles होते हैं वो oscillate नहीं करते along the line of wave propagation, but oscillate up and down about their mean position. That means perpendicular to their mean position, right, as the wave travels. So example for these transverse waves are the light waves. Now we will discuss about the unit of sound. As we all know, the common unit is decibel. Noise of the sound is being measured in this. And another one is hertz. Unit of sound frequency. Unit of frequency of sound is hertz, right? It can be denoted by Hz. So what is frequency? The number of cycles of sound wave in 1 second. Alright, next we will discuss about audible range. What is audible range? Our humans hearing range. जो आवाज़ आपको सुनाई देती है, that is your hearing range. And what is our hearing range? It is 20 Hertz to 20,000 Hertz. I again repeat myself, our hearing range is 20 Hertz to 20,000 Hertz. Humans can typically hear starting at 0 decibel. And sounds more than 80-85 decibels can be dangerous for our ears, right? Our eardrum may get burst if the sound will be more than this. But the sounds below the 20 Hertz we will not be able to hear, not above the 20,000 Hertz. We are having a definite hearing range with us. Okay, so next we are going to discuss about longitudinal waves. Longitudinal waves can go through a slinky. What is slinky? Slinky is type of spring. What I have done, I have taken a spring, and if I'll hold one end of that and fix the other end to the wall through an iron nail, एक कील लगा दी मैंने दीवार पे और उसमें उसका एक सिरा अटका दिया, and I'm stretching the other end of it. What will happen? Once I have stretched, and after that I'll allow it to move towards the wall. पहले ये थोड़ा आगे की तरफ जाएगा and again it will come back. When it will move in forward direction, what will happen? कुछ regions बनेंगे जहाँ वो मूव करता है, कुछ रीजन्स बनेंगे जहाँ पर कंप्रेशंस बनेंगे और कुछ में रेरिफ्रैक्शंस बनेंगे. नाउ वी विल डिस्कस मोर अबाउट कंप्रेशंस एंड रेरिफैक्शंस. ऑलराइट. Yes, see, this is a slinky, right? What I have done, I have stretched its one end. What will happen? It will somewhere, as I have told you, compressions will be made and somewhere rarefaction. So what are compressions and rarefactions? Now we are going to discuss. Compressions means when you will allow it to leave. Whenever sound travels as successive compression and rarefaction in the medium. A vibrating object producing a series of compression and rarefaction, as you are able to see in this picture, right? When a vibrating object moves forward, it pushes and compresses the air in front of it. जब ये आगे की तरफ जाएंगे vibrating object, तो क्या होगा? आगे की तरफ ये पुश करेंगे और वहाँ जो एयर फिल थी उनके बीच में उसको कंप्रेस करेंगे, राइट? और वहाँ पर हाई प्रेशर का एरिया क्रिएट हो जाएगा. ओके, I'll explain it to you with another example. You guys have made a queue, right? You have taken one hand distance with one another, but suddenly someone pushed you from the back. और आप आगे की तरफ जाते हैं और आपकी वजह से जो डिस्टेंस है सबके बीच में जो एयर थी वो फिनिश हो जाती है. आप आगे की तरफ जाते हैं. व्हाट विल हैपन? यू विल कंप्रेस द एयर इन फ्रंट ऑफ यू. जितनी भी आगे एयर थी, जितने भी लोग थे, वो सारे कंप्रेस हो जाएंगे. जो एयर थी आगे वो कंप्रेस हो जाएगी एंड वहाँ पर आप ओवर क्राउडेड हो जाओगे, हाई डेंसिटी हो जाएगी एंड हाई प्रेशर का एरिया क्रिएट हो जाएगा, राइट? So when a vibrating object moves forward, it pushes and compresses the air in front of it and form a region of high pressure, which is called compression, denoted by C. All right. And so there will be particles will be overcrowded over there. Okay. And we can show this with the help of the peak, right? The upper part. As I have told you, it always moves through a wave. Okay. So when the vibrating object moves backward, now we will talk about what? The rarefaction. What is rarefaction? When the vibrating object moves backward, आगे की तरफ जाके जब ये पीछे की तरफ आएंगे, when the vibrating object moves backward, it form a region of low pressure, which is called rarefaction. Okay, are you able to see over here the rarefaction as well as the compression? Compression में high pressure का area create होता है and rarefaction में low pressure का area create होता है. All right, now we are going to discuss about the characteristics of sound wave. I hope the rarefaction must be clear to you. Okay, rarefactions low pressure और low density के areas होते हैं. Okay, where the particles are spread out and are represented by the lower portion of the curve. You can call it trough, you can call it valley also, you can call it rarefaction also. All right, see, if this is a line and this is a wave. Okay, so what is this? This is compression. And what is this? This is rarefaction. Okay, you can also call it what I told you, hill. And इसको क्या बोल सकते हैं? वैली. दूसरा नाम क्या है? You can call it crest and you can call it trough. Okay, so these three names you can give to them: compression, hill, compression, hills, and crest, rarefaction, valleys or troughs. Okay, now we'll discuss about the characters of sound waves. The first characteristics of sound wave is amplitude. What is amplitude actually? See, if this is a wave, all right, so the amplitude of sound wave is the height of the crest and the trough. Okay, जितनी height है crest की या trough की, this is called the amplitude. All right, so in a sound wave, the maximum displacement of a particle from its mean position. What is amplitude? Displacement from its mean position. What is this? This is the mean position. Okay, and displacement from here is known as amplitude. Okay, which is denoted by A. And what is its SI unit? It is meter. All right. Now, amplitude. Amplitude always depends on the force. See, if I am striking this table, what happens? Sound is being produced. If I strike it with less force, you will be able to hear less sound. If I'll strike it with more force, you will be able to hear more sound. How? Because if I'll strike with more force, what will happen? There will be more displacement to its mean position. So, when I am striking it hardly, the amplitude will be higher. And if I am striking it with less force, the amplitude will be less. Okay, so this is the amplitude, displacement from its mean position. Okay, the next character that we are going to discuss is the wavelength. Now, what is wavelength? If this is a wave, the distance between two consecutive crest or trough is known as wavelength, which can be denoted by lambda. Okay, so it is the distance between two consecutive compression, or you can say two consecutive rarefaction, which is denoted by lambda, and its SI unit is meter. Okay, next we are going to discuss about frequency. What is frequency? It is the number of vibrations occurring in 1 second, right? If this is a wave and I am saying this much vibrations are occurring in 1 second, then this could be said as frequency, which can be denoted by nu, right? So how can you write it? It could be written as like this, nu. Okay, so what is its SI unit? Its SI unit is hertz. Okay, we can calculate the frequency of sound by calculating the number of compressions or rarefaction. एक सेकंड में कितने कंप्रेशन और रेडिफ्रैक्शंस बन रहे हैं, वो उसकी फ्रीक्वेंसी कहलाएगी. सो फ्रीक्वेंसी का फॉर्मूला क्या होगा? फ्रीक्वेंसी न्यू इज इक्वल्स टू number of vibrations in 1 second. How much time? Number of oscillations upon total time. This is the formula to find out frequency. Alright. Now we will discuss about time period. What is time period? The time taken by the particle of the medium to complete one oscillation. एक वाइब्रेशन करने में कितना टाइम लग रहा है वो उसका टाइम पीरियड कहलाएगा. And you can denote it with T and its SI unit is seconds. Okay. Now we'll discuss about V, velocity of sound wave. It is the distance travelled by a wave in 1 second. What is velocity? It is same as speed. So the distance travelled by a wave in 1 second, that is known as velocity. And it is represented by V. So speed with which compression and rarefaction move ahead. जिस speed के साथ, जिस velocity के साथ compression and rarefactions are moving ahead, that is called their velocity. And the speed of sound is more in solids, less in liquids, and least in gases. Alright. And tomorrow we will discuss in the next video about the relationship between speed V, frequency nu, and wavelength lambda. Till then, stay home, stay safe. Thank you.